Question 1. What does it mean that the Venn diagram shows obtuse, partially overlapping isosceles? So in our Venn diagram here, we have our obtuse right here. We know we're talking about our triangles, and isosceles just shows us just a little bit. So what does this tell us in comparison with just these two triangles, my isosceles triangle and my obtuse? We already know isosceles means we have two sides of our triangles that are the same length. Obtuse means we have a angle that is larger than 90 degrees in there. So let's think about it and solve our answer. And for our answer, our Venn diagram is showing us here that an isosceles triangle can also be an obtuse triangle, or an obtuse triangle can also be an isosceles triangle. That means I can have a triangle that has an angle that is larger than 90 degrees, and it can also have two lengths that are equal in length or in size. All right, so again, our Venn diagram is helping us understand the categories of our polygon. Question 2 says, the Venn diagram shows categories of quadrilaterals with different properties. Write the name of each category that fits the description. So here, we need to answer, we already see that for 4 sides, it says it's our quadrilaterals. It says B, at least one pair of parallel sides, that's going to be our trapezoid. C, it says 2 pairs of parallel sides, we need to answer this, D, E, and F. Also, let's fill in our chart here. I want you to do this on your own. It's the same thing you would already have here. It's just going here. So the same answers you have here, you put in here. Let's pause the video and answer. When answering our questions or filling in our Venn diagram, we can see that for C, it says 2 pair of parallel lines. That's going to be our parallelogram. We know our parallelogram can look sort of like this. Going to be our parallelogram. Next, we're going to have our D is going to be our rhombus. It says 4 sides, 2 pairs of parallel sides, and 4 sides of equal lengths. So we're going to have our rhombus here. We got 2 parallel sides, so it's going to be the same lengths, but the sides will be parallel. Next, we have our square here. E will be our 4 right angles, which is our rectangle. And for F, we had our square, which is encompassed. B, we already had our trapezoid. And for A, we had our quadrilateral, which is all of our 4 sides. Next, we're going to take our time and answer the question 4. It says, is every property of a parallelogram also a property of all rectangles? Let's think of that first. Let's think about properties of our parallelogram, but then think about properties of our rectangle. We can go back to this slide also. We saw what our parallelograms were. And let's look at our rectangles. Parallelogram, 2 pairs, parallel sides. Rectangle, we know is 4 right angles. And we're going to go to the same thing as every property of a rectangle, also a property of a parallelogram. And it says explain what the Venn diagram shows about the relationship between the rectangles and the parallelograms. So based on what we just saw on our page previously, let's answer these questions. Let's pause our video and answer. So if I look at my Venn diagram and I compare my parallelograms to rectangles, so do all properties of our parallelogram, are they also in our rectangles? So we can see our parallelogram is inside of here and our rectangles are on the inside. So all of our properties. So the question for the answer for A is every property of a parallelogram also a property of a rectangle? Answer should be yes. All right. Next, it says every property of a rectangle also a property of a parallelogram. For a rectangle, it says it has 4 right angles. Does a parallelogram have 4 right angles? No, it does not. It does not have 4 right angles, so the answer should be no. But we saw, does it have 2 pair of parallel sides? Our rectangle did have 2 pair of parallel sides. So that's why our answer for the first one is yes, and the next should be no. Next, it says explain what the Venn diagram shows in relationship between the rectangles and our parallelogram. So what we see here is that all of our rectangles, as we see here, this is our rectangle circle, and all of our rectangles are inside of our circle of our parallelogram. So all rectangles can be parallelograms. all rectangles that have four right angles, they will all have two pair of parallel sides. But what it shows is that not all parallelograms will be rectangles. So although it may, just like we see here, we have a parallelogram here, but it is not a rectangle. So not all parallelograms will be a rectangle. But this parallelogram, this rectangle here, is a rectangle. So to answer our question, we will have all rectangles are parallelograms, but not all parallelograms are. Question 5 and 6 is asking us to determine if the statements are true or false. It said, and if it's false, we need to explain why is it false. So for 5, it says the opposite angles of a parallelogram have the same measurements. Therefore, the opposite angles of any rhombus have the same measurement. We need to determine if it's true or false. And for 6, it says the diagonals of any square are the same lengths. Therefore, the diagonals of any rhombus are the same lengths. Let's pause this video and answer 5 and 6. Okay, so for 5, it says the opposite angles of a parallelogram have the same measurements. Therefore, the opposite angles of a rhombus have the same measurements. This is true. What this means is that these two angles are the same, just as these two angles are the same. For 6, it says the diagonals of a square are the same length. Therefore, the diagonals of a rhombus are the same lengths. This is saying that these two measurements would be the same. These two measurements would be the same because it appears to think that rhombuses and squares would be the same. But in all actuality, that would be false because not all rhombuses are square. We can see that in our Venn diagram because we have our rhombus here. Although it overlaps a little bit of the square, we still have a good dimension of it that's not. So all rhombus are not square, so they wouldn't all have the same dimensions there. So for 6, we will have false. We want to use this chart, the flow chart above, to answer 7 and 8. 7 says, in every rectangle, the two diagonals have the same length. Therefore, in every parallelogram, the two diagonals must have the same length. Is this true or false? Let's pause, look at our Venn diagram, and answer 7. We know this answer would be false because here we already see that our parallelograms go into our rectangles and our rhombus, and we know our rhombus does not have the same diagonal lengths, which is what we answer here. Not all rhombuses are square, so all of the same diagonal sides will not be the same length. So we know that 7 could be false. 8 says, every rhombus has at least 2 lines of symmetry. Therefore, every square has at least 2 lines of symmetry. We know this is true. This is true because we also know that each square has 4 equal sides, and it is 4-sided, so it can have at least 2 lines of symmetry. This should be true. Now we're on to our guided practice. Question 9. It says all polygons are either convex or concave. A convex polygon has an interior angle less than 180 degrees. A triangle is an example of a convex polygon. A concave polygon has at least one interior angle greater than 180 degrees. A quadrilateral below is an example of a concave polygon. So here we have an example of a concave polygon because this interior angle, 210, is greater than 180 degrees. Okay, so it says categorize concave polygons, convex polygons, triangles, quadrilaterals, and rectangles in a Venn diagram. And draw an example of each polygon in the Venn diagram. So what we want to do is draw a Venn diagram like we did in our previous 2 pages. And we want to make an example of each of these and make sure we're able to show how they are either alike or not. Let's pause our video and go ahead and give it a shot. After looking at our different shapes we need to compare, we see that we can start with our convex, and we can have our triangle being our first. We saw our convex polygon has an interior angle less than 180 degrees. We know all of our angles in our triangle will equal 180, so these interior angles will be less than 180. This is a 90 degree. Since all of our interior angles on a rectangle is 90 degrees, we know that it's going to be less, so these are all going to be convex. Our concave can be here. We said we know that one of our interior angles, which is here, is going to be more than 180 degrees, more than, so we know that one of our angles will be that. We can say that one here, this one here could be more than 180, as well as this one, these two. Just like this one here, we know this angle here can be more than 180, so it'll be concave. But because these two angles have 4 sides, we know they both can be considered quadrilateral. All right. Now we're on to question 10. It says, N said that rectangles can never be called trapezoids. Explain why N statement is incorrect. So we can use our Venn diagram from our previous page to help us answer why this statement is incorrect. Let's pause and give it a try. After you're done, go ahead and move to 11. It says, describe the properties of a shape that is both a rectangle and a rhombus. And name the shape and use the grid below to draw it. So for 10, it's asking us to explain why she is incorrect, saying that a rectangle can never be called a trapezoid. We know that before, trapezoid said that it had a pair of parallel sides. So because a rectangle has at least one pair of parallel sides, we know a rectangle can be considered a trapezoid. For 11, we need to have a shape that has both characteristics of a rectangle, which means it has 4 right angles, as well as the opposite sides are equivalent or parallel. So that's going to be our rhombus. Our opposite sides being parallel will be our rhombus, which is what we have here, both opposite sides here. And then we have 4 right angles, which is what we have here. So this can be a square. Once you are done with question 11 and you have drawn your square here, go ahead and move to your independent practice, which is our next page. You want to do the next page on your own. This is your exit ticket. Complete it. Make sure you submit it through your Nearpod. Make sure you show all of your work.